finally, folks, let's talk a little bit about quaternary structure. So proteins with quaternary structure are made up of more than one individual peptide. They are generally very, very large, and we call each of these peptides a subunit. So for example, this protein has 1, 2, 3, 4 subunits. The quaternary structure describes the way that these various subunits come together to make the final protein. Now, these subunits, when they come together, are mostly sticking together through non-covalent interactions. Of course, some disulfide bonds can occur. Again, those are bonds between two cysteines. But largely, what's holding this quaternary structure together is non-covalent interactions, and in particular, non-polar interactions between subunits. So this idea is similar to the protein folding idea governed by the hydrophobic effect. If this protein exists in quaternary structure where the interface between the subunits stuck together is always excluding water, we would expect kind of the strongest force holding that together would be the hydrophobic effect, to bring these subunits together to interact favorably while excluding water, increasing the entropy of water. Now, quaternary structure comes in all shapes and sizes, as shown to you on this screen. There's a lot of different geometries that exist for quaternary structure. And we could say a quaternary structure is a dimer if it's made up of 2 proteins, or a tetramer if it's made up of 4 proteins. Real quick before we wrap up, I just want to make sure 2 of our vocabulary words are clarified. So firstly, domain is going to describe a distinct region in a protein. With a specific function. And we can think of a domain as existing within a tertiary structure. Subunit is an individual peptide or protein that makes a larger protein with quaternary structure. So I just wanted to make sure that those 2 things were kind of separate in our minds. Domain and subunit. That wraps up the series of videos, folks. We've talked about primary, secondary, tertiary, quaternary structure and what they are. But what I want us to focus on is understanding how secondary structure is stabilized and how tertiary structure and folding is stabilized. With that, I'll leave you with this homemade cat meme.